Welcome to our presentation for RH330. Today, we're talking about nuclear fusion, its history, its future, its benefits, and especially why we think that negative popular opinion is one of the biggest obstacles facing the creation of effective nuclear fusion. But first, a little bit about ourselves.
Before continuing with our proposal presentation, we would like to quickly introduce the team. There is myself, Joshua Erpenbeck, Joseph Lehman, Clayton Shire, and Clea Hodes, and we are the Advanced Fusion Professionals.
Our team believes nuclear fusion can be used as an energy source. Now, the reason we believe that is we did some research regarding global energy consumption. And as provided by the graphic, we found that 84% of the world's energy consumption is provided by non-renewable energy sources, such as oil, natural gas, and coal. Now, the Met Group, which published the article along with this graphic, went on to explain that oil and natural gas will be depleted in less than 55 years, around 50 to 55 years. Now, this creates urgency around the world from general public, world leaders, in finding a new energy source that can provide energy for years to come. Our team believes that nuclear fusion is that option, and it is the right option to make. Now, this is not to be confused with nuclear fission, which is sort of similar, but there are some big differences where nuclear fusion is proven to be the better option than nuclear fission, and we're going to explain that throughout the PowerPoint presentation today. But first, a good background on nuclear fusion is...
The first steps in the development of nuclear fission occurred in the late 1800s. This included the discovery of the element uranium and deepening the understanding of the atom. In the early 1900s, scientists started experimenting and began to notice that nuclear transformations would occur whenever a neutron would collide with the uranium atom. These nuclear transformations had huge potential of heavily impacting World War II in the form of nuclear weapons. The United States government made this a top priority and founded the Manhattan Project with the goal of creating a nuclear weapon. In the span of 3 years of nuclear weapon development, the United States' best scientists had successfully created a working atomic bomb. Once World War II is over, the mindset for the use of nuclear energy changed. The new potential was not in the form of weapons anymore, but in the form of commercial energy. This transition is what started the first generation of nuclear energy. This newly created generation resulted in multiple power plants being built all over the world. And even though these newly created plants are doing a wonderful job providing practical energy to society, they unfortunately went through multiple disasters. And such disasters included the 3 Mile Island reactor and the Chernobyl nuclear power plant. And even though these reactors were doing a great job and being very beneficial to society, people only remember these first-generation reactors for their disasters. As a result of the past disasters of the early generations, the nuclear energy industry began enforcing increased safety and regulations to power plants. In addition to this increased safety, new types of power plants were being designed, and this included variations such as the light water, the heavy water, and the economic simplified boiling reactor. Perhaps some of the most significant improvements of these newer generations as opposed to the past generations is the incorporation that some designs have passive safety features, and these safety features do not require active controls or operator invention, but instead rely on gravity or natural thermal convection to mitigate the impact of abnormal occurrences. With the combination of advanced safety regulations and improved power plant designs, the disasters began to disappear, and this resulted in nuclear fission emerging as the obvious candidate for the best commercial energy source. However, nuclear fusion is a different story. Even though fission is a great energy source and has been very beneficial to society, it is nothing compared to fusion. And despite the Generation 3 Plus designs being extremely advanced and requiring a lot of engineering and science, fusion would blow that all out of the water. This revolutionary energy source is unmatched, and if society were ever able to attain fusion, the world would change drastically. There would never be another energy crisis ever again.
Now that you've had some history and background of nuclear energy, we can talk more about the process. Nuclear fusion is essentially two small nuclei combining to form a larger one, and in the process creating a large amount of energy. This energy is created due to there being a loss of mass during a fusion reaction. The mass of the two nuclei independently is greater than the mass of the larger combined nuclei. This means that there's a loss of mass through this reaction, and this loss of mass is converted to energy and can be modeled by the famous equation E equals mc squared, where m is the mass loss and E is the energy produced. Nuclear fission, on the other hand, is kind of the opposite of nuclear fusion. It is the splitting of a larger nuclei into two smaller ones. This breaking of the nuclei creates a lot of energy because the bonds inside of a nuclei are so strong that the act of breaking them releases this energy. This is called the binding energy. Fusion creates much more energy than fission, almost 10 times as much, but both produce much more energy than many other sources. Nuclear energy on Earth has pretty much only consisted of nuclear fission. One reason for this is because it's much easier to break atoms than to join them. For a fusion reaction to take place, there must be extremely high temperatures and pressures. It needs to overcome the repulsion of protons and have enough pressure so that they can fuse. Fusion reactions mostly take place in our sun, which has these conditions, but producing these conditions on Earth is much harder. Fission does not need these intense conditions for a reaction to take place. So most nuclear energy on Earth has been nuclear fission, even though nuclear fusion is a much better source. Nuclear fusion is much safer than nuclear fission in a number of different ways, and we'll talk about that next.
Now that nuclear fusion and nuclear fission have been differentiated and you now know some key differences between the processes of creating energy with those two, I can get into the actual safety differences of nuclear fusion versus fission and why nuclear fusion is the better option in terms of safety. Now, there's two pretty main differences between nuclear fusion and nuclear fission safety-wise. The first being the chances of nuclear runaway. Now, with nuclear runaway in fission, it can be an outside source affects something with the process, and the nuclear process runs away, gets way too hot, and there's an explosion, and it's really bad. That's short term. Nuclear fusion doesn't have the chance of that happening. The process is such a precise and delicate process that any outside source affecting it will just shut it off. The plasma involved in the process will cool off immediately. And this was being described by ITER, who is the International Nuclear Fusion Research and Engineering Project, which is backed by 35 different nations. Now, that was short term, more like catastrophic. What if that happened? Now, long term is the actual byproducts of this process. Now, fission does have some toxic byproducts that come with the process, and that's a big negative with it. You can't really, it's hard to get rid of those. Now, nuclear fusion does not have those same byproducts. The process does not produce toxic gases, no toxic waste. So in these two aspects, long-term and short-term, nuclear fusion is definitely the better option compared to fission. Now that I have described the safety parts of nuclear fusion, we can get more into the actual possibility of using nuclear fusion as an energy.
Contrary to what most people believe, fusion has actually already been achieved. But the problem is that these fusion reactions are not able to be sustained for long periods of time. The longest fusion reaction was sustained for 101 seconds using a tokamak. A tokamak is a donut chamber reactor, and this particular 101 second reaction took place at the experimental advanced superconducting tokamak in China. This reaction time may seem small, but relative to past reaction times of only a few milliseconds, 101 seconds is extremely large. Once scientists, physicists, and engineers are able to produce large enough temperatures and pressures to achieve longer reactions, fusions can then be used as a commercial energy source. The notion that fusion is impossible comes from the fact that we need to basically recreate conditions that mimic a miniature sun on Earth. Despite being extremely challenging, progress is continually being made and breakthroughs are occurring quite often. It is just that the requirements for fusion on Earth are so challenging that these progressions may seem small in the big picture. The best chance of practical fusion occurring is at the International Thermonuclear Reactor in France. 35 nations are working together on this reactor, and this is the largest tokamak ever built. The building process has taken 10 years, and the tokamak is on schedule to test its first plasma in 2025 and achieve full fusion in 2035. The full fusion is expected to have a reaction time of 400 plus seconds. Time and continued innovation is what fusion requires, and humanity still has a good chance of achieving this perfect energy source.
One of the great advantages of nuclear power is the energy density associated with it. In a 2015 study concerning the comparison of different power generation techniques from the University of Bath in the United Kingdom, the primary advantage of this energy density was highlighted quite starkly. As you can see, the energy per square kilometer used for nuclear energy absolutely dwarfs all of solar, wind, and biomass. Uranium, deuterium, and tritium, and other heavy metals just have the capacity to produce much more concentrated power. And this directly translates into the land area required to host power generation. A 2002 study out of Japan documented the land required for different power generation techniques. As you can see, areas where land is a premium, nuclear energy is a standout at just half a square kilometer required per terawatt hour. Compare this to coal at 4 square kilometers per terawatt hour, or even solar at 45 square kilometers per terawatt hour. Nuclear energy is far more efficient when it comes to land use. But this isn't the only aspect of fusion power that would be particularly beneficial. Fusion is universal because it could be implemented anywhere. Because fusion is a completely controllable reaction, it wouldn't be dependent on a region's natural resources. For example, fusion reactors could operate regardless of daylight levels, or they could operate regardless of whether there's wind. This also means that fusion reactors would have a more constant output as opposed to being dependent upon peak sun or peak wind. It's not dependent on large swaths of land or the availability of water features. And not only does fusion have benefits in the present, the long-term ramifications are not as severe as nuclear fission.
One benefit of nuclear fusion is the byproducts. Nuclear fusion creates an abundance of energy with no long-lived nuclear waste and no emissions of greenhouse gases. Helium is the main byproduct of nuclear fusion reaction, and having more helium is more of a positive than anything, as the current instability in the supply of helium has been difficult for some industries. The concern that many have about nuclear waste is about the waste created from nuclear fission, not nuclear fusion. Nuclear fission reactions use uranium-235, which is a radioactive material with a half-life of 700 million years. The most radioactive element in nuclear fusion is tritium, which only has a half-life of 12.3 years. The half-lives are indicators of how long the waste will be around and emitting radioactive particles. Fission creates nuclear waste that lasts millions of years, while fusion has no real long-lived nuclear waste. Yes, nuclear waste is an issue, but it's not an issue in nuclear fusion. In addition, nuclear fusion and nuclear energy in general creates no greenhouse gases, which makes it way more sustainable than most sources of energy. Currently, the use of nuclear energy is reducing over 555 million tons of emissions
To
per
convince
year.
the public that nuclear fusion is the best option for energy going forward, we had to think of a way to get a hold of the largest amount of the public we can. And based on research by the Pew Research Center and also Edison Research, we found that 7 out of 10 people that were surveyed in this Pew Research survey said they use at least one form of social media, as you can see by the graphic. Now, we also wanted to go further and say, well, just using social media, people scroll by a bunch of stuff all the time. So we wanted to do podcasts. And Edison Research did a research paper on what podcast was the best going into Q2 of this year, 2021. And they found that the Joe Rogan Experience was the #1 podcast for all podcasts on streaming sites. So we had the idea to send a letter to Joe Rogan asking him to talk about our nuclear fusion and the research that we did, and even do his own research, look into it, see what was better and what was not as good about nuclear fusion, just to get people talking about it, because that's the best way that we found that we can get the public's opinion of nuclear fusion to change for the better.
One of humanity's most startlingly brilliant achievements was traveling to the moon and back. A staggering feat by any measure, this was only made possible by the determination of people in public support. We see parallels between the journey to the moon and the development of effective nuclear fusion. Without public support, it simply will not happen. But if people decide this to be a worthy endeavor, the many complications facing nuclear fusion can be overcome. And so we ask you, become an advocate. At the heart of our issue is the fact that the campaign against nuclear fission has shifted over to nuclear fusion, and we don't think this is valid. You can change that. The only way to shift popular opinion is by the efforts of many, many people. With the advent of social media, it's now easier than ever. Talk to someone, tell the world, pressure an influencer to use their platform to talk about the positive future of nuclear fusion. If you have a platform, use it. Advocate for support of nuclear fusion. And we would like to give a warm thank you to our sources referenced in this presentation, and thank you for your time.